So I'm assuming that most of you watching this are familiar with drawings in 3 points perspective. Some common examples are often drawings that are drawn from what is referred to as a bird's eye view when the viewer, or in our case the camera, is looking down, or a worm's eye view when they are looking up. To put it simply, a third vanishing point appears when we tilt the camera up or down. In doing this, the line of sight and therefore the picture plane is angled to the ground plane, and our centre of focus point or centre of vision along with the eye level is above or below the horizon line. All of the examples that I've created so far throughout this series were drawn in 1 or 2 points perspective, for which the line of sight remains parallel to the ground plane, and you can also see this in what I've decided to refer to as the spectator's view. It's important to remember that as we move the camera, a lot of what you see here is fixed. This includes our picture plane, cone of vision, line of sight, centre of vision line, centre of focus point, and our eye level. The station point is the position of the viewer's eye or our camera, and so as we turn our head to look around or move our camera, all of this is fixed, it cannot change. Imagine wearing a helmet that had all of this stuck out in front of you. Now there's a lot to explain as we get into this, but just try and bear with me. Yes, I'm talking to you, Boxman. We understand now how a setup like this translates over onto paper, but how do we do that when we tilt the camera like this? First of all, it's important to understand that all we are really changing here in doing this is the camera direction. The camera is tilting downwards, and all we need to know is how this movement translates over onto our paper when setting this up. I'm going to show you how to do this as I create a drawing of what's going to be a perfectly square box. I'm also going to approach this in a way that gives us, being the artist, control, meaning we get to decide what lens we want to use, the angle of the subject and how we view it, and also, in this case, the angle of tilt. Again, it goes back to my being a director analogy. So I'll run through this first example, drawing it by hand, and then do more of this digitally so that I can scale things up easily and create some useful grids to draw with. To begin, I'm going to start by drawing in what will be our picture plane, something that you are all familiar with now, and that goes for a lot of these other elements. Now, right down the middle of my picture plane, I'll draw my centre of vision line. In addition to this vertical line, I'll also draw a horizontal line across the middle like so, and this will be my eye level. Where these two lines intersect will be my centre of vision point. Again, this doesn't have to be directly in the centre of the picture plane, but in most cases it will be. This centre of vision point is always at the centre of our cone of vision, and as I've done in previous examples, I'm going to draw in this circle so that it covers our picture plane, and this is to avoid any unwanted distortion, which, as you know now, occurs when we are towards the edge and outside of this circle. At this stage, I have what could be the start of a drawing in 1 or 2 points perspective, except now is when we start to approach this in a different way. Firstly, I need to decide on what lens to use. For this example, I'll use a standard lens with a 60-degree angle of view. Instead of lining this up on my vertical line, I'll do this to the side here along the eye level line. I'll explain in a moment. Each of these lines are at 30 degrees and are lined up to meet the points at which the circle for the cone of vision intersects the centre of vision line. And where they meet on that eye level line establishes what is referred to as a vertical station point. Here, the station point is flapped over to the side of this due to it representing verticality now. In the same vein as establishing a station point in 1 or 2 points perspective, we are representing what is essentially a 3-dimensional scenario on a 2-dimensional surface. That's why we have to flatten this out. In reality, the station point exists up here, right? It's the position of the camera. Flipping this over to the side is the same as flipping down that same distance between the camera and the picture plane, like we did when establishing a station point in 2 points perspective. I'll still be locating that station point later, but right now if this doesn't make much sense then don't worry too much, I will be going over this again. Now as I mentioned earlier, we are setting up a drawing in which our camera is tilting forwards or backwards. In this example, I want my camera to be tilting forwards to look down at the box here, the same way as it is in the spectator's view. Now before I do that, it's probably best to mention that when it comes to drawing in 3 points perspective, your eye level and horizon line are no longer the same. Instead, the horizon line stays where it is, and as we tilt the camera, or our head if we are referring to a person, the viewer, to look up or down, the eye level moves away from it. Remember, the eye level is something which is fixed to the viewer, and so looking at this example here, if this is the eye level and I'm saying that I want to tilt the camera to look down at the box, then I know that my horizon line will be up here somewhere. The larger the degree of tilt, the further away our fixed setup here, including the eye level, will be from that horizon line. Now this is where things get interesting. There's not a lot of content out there covering this, what is, let's say, a more mechanical way of setting up a drawing in perspective. As I mentioned earlier, I'm trying to find the best approach which allows us, as the artist or the director of a camera, to have the most control and in turn influence the resulting drawing. So, with that in mind, it's at this stage when I need to decide the degree of tilt. In this case, let's say I want to tilt the camera 40 degrees. From the vertical station point, if I draw a line at 40 degrees and extend this across, it will eventually intersect with the center of vision line. It's at this point where I can then draw in my horizontal horizon line. So, as you can imagine, if I had a larger degree of tilt, this line would intersect my center of vision line higher up, meaning the horizon line would also be higher, which makes sense. So at this stage I have a lot of information to work with. I've set up my camera with the lens of my choice and tilted the camera forwards 40 degrees. But there's not enough to start drawing just yet because I still need to locate some vanishing points, 3 vanishing points in fact. Now we already know that through tilting the camera like this, we've already created a third vanishing point, but the question is, where is it? To find that third vanishing point, or vertical vanishing point as it's often referred to, I can make use out of the fact that I know my degree of tilt line is at 40 degrees from this station point. As noted in previous videos, 90-degree relationships are essential, and this is another example of that. I need to draw a line from my vertical station point, one that is at 90 degrees from that degree of tilt line, and I extend this until it meets the center of vision line. The point at which it meets that is the position of my third vanishing point. And it makes sense that the degree of tilt dictates the position of that. I'm aware that this is a lot to take in. Boxman is looking like he's lost all hope at this point, but I will be producing many examples of this, so don't worry too much if you are feeling the same as him. But as you might have guessed, all that's left to do now is find a left and right vanishing point. Now, when I was learning how to do this, I was trying to figure out how, in the same way as we did when drawing in 2 points perspective, we can accurately locate the position of the left and right vanishing points based on what angle we decide to view the subject on. If you have watched the previous videos, you'll know that we do that by taking 2 lines at angles totaling to 90 degrees from the station point and see where they cross the horizon line, but in this case we have a vertical station point over here, but what we are missing is, I suppose I could refer to it as a ground plane station point. Now, to find that, we can simply swing this line, this distance from the vertical station point to the center of vision line, down until that meets the center of vision line again, and the point in which it does is the location of the station point, which we can then use to position our left and right vanishing points on the horizon line at any angle we want. For this box that I am drawing, I'll place one vanishing point at 30 degrees and one at 60 degrees, totaling to 90. At this stage, I can connect these up like so, taking some lines from each of these vanishing points down to that third vanishing point below. Seeing as I am drawing a box, what is a perfectly square box in this example, it also helps to find some 45-degree reference points. Now before I open up that can of worms, I want to say that at this stage you are good to go. You have all 3 vanishing points, a cone of vision that is based on a lens of your choice, and you've also set a degree of tilt and rotated this box around on a desired angle. At this stage, I'd usually construct a grid, scale this up, and then start drawing. I'll be creating more examples like this in future videos as well. So, Boxman, it looks like you've had enough, but we are not done yet. This is a chance for you to prove to the world and to yourself that you are who you say you are, an expert when it comes to perspective drawing. So sticking with the same setup as I have created up to now, everything is locked in and making sense now. One thing to note is that there is a 90-degree relationship between each of these vanishing points. Now, as I said a moment ago, when drawing what is a square box like this, it helps to find some 45-degree reference points, and in order to do that, we also need to find what could be referred to as secondary station points. These are station points that are specific to each of these relationships. Just like when we establish a vertical station point, we are taking what is actually a 3-dimensional point out here in front of the cone and flipping that distance down. We also did that when locating the station point down here. This is a 90-degree relationship between the left and right vanishing point. We can also find that same point for the left vanishing point and third vanishing point, and also for the right vanishing point and third vanishing point, and I'll do that in a moment. In general, it's important to understand that these 90-degree relationships and the points which are established from them allow us to draw objects in perspective with 90-degree faces, boxes. We know, for example, that when we extend some lines from these vanishing points to draw a box, that these lines are at 90 degrees, but that's not so obvious when being viewed in perspective. Just like how a square in perspective can often appear to be a rectangle. So the purpose of these secondary station points is to find the real 90-degree angle for each of these relationships on our setup here. And again, this in reality would exist out here as we look at the subject, but we flatten that to be viewed in 2 dimensions. If I draw a line from, let's say, the left vanishing point here, through the centre of vision point and extend this, you'll see that it meets this right wall at 90 degrees. The same applies to the right vanishing point. A line extended through the centre of vision will meet this left wall at 90 degrees as well. These are essentially centre of vision lines for each of these vanishing points, on which a station point for each of these can then be found. I'll start by finding the station point for the right vanishing point and vertical vanishing point. Now this is where it gets tricky, because in order to find this point I use a triangle. This is the largest one that I have. Again, this is why I often prefer to set this up digitally, but I line this up so that the corner of this is placed along that line and either side is lined through to each of these vanishing points. I can mark on that point and take some lines back to them. And then this creates what is another flap, right? Just like any of these other station points, in reality this would lift up. All station points meet and exist at the true position of the camera. So I can also do the same to find a station point for the left vanishing point and the vertical vanishing point. Again, I line this up, mark a point at this corner, and then construct another, what I'm referring to as flaps. Imagine these to have hinges. So these station points represent a 90-degree meeting point for each pair of vanishing points, and this is really useful because it means I can now identify other angles and essentially transfer them over into perspective, such as some 45-degree reference points. Now, you can use a triangle or a compass to do this. Here you'll see that I find this 45-degree angle on each of these flaps, and then I extend a line to the relevant wall. I mark a point for each of these, and I also do the same for our ground plane station point, finding a 45-degree reference point on the horizon line. This is something we've done before when drawing in 2 points perspective. Finally, I am ready to draw in this box, what will be a perfectly square cube. So, Boxman, are you following along? Boxman? I don't know where he's gone. Anyways, I start by drawing this front vertical edge of the box at a size of my choice. This is angled converging to the vertical vanishing point below. Now, at either side from the top and bottom of this, I'll extend some construction lines to both the left and right vanishing point. This is where our 45-degree reference points come into play, because instead of estimating where to end these two side planes for this box, I can take a line from the top of this edge back to that reference point, and where this crosses the bottom edge of these side planes is where I need to cut these off. These are foreshortened square planes, accurately drawn in perspective. For the top plane, I do the same, taking a line to that 45-degree reference point on the horizon line. So there we go. Once we have all of this, it's fairly straightforward. I will be going over this again and creating more examples in the next video, but that's an introduction to what's involved in setting up a drawing in 3 points perspective this way. Although it seems like a lot to take in, it does start to make a lot more sense once you draw this out and become more familiar with the steps involved. As always, I will be posting a study document over onto my Patreon page, which covers what was discussed in this video. Be sure to check that out if you are interested. With that being said, thanks for watching, and I'll see you in the next one.